I put a lot of effort in reducing binary size. And that's something that's not even a feature that most users think about. Like it doesn't end up in the docs or anything, but it's actually super important. And I started counting and I realized that if I could shave off just 1 MB off of a NumPy binary, that would save on the order of 200 intercontinental flights a year. There are large error bars on this number. You can go to PyPI stats and it will tell you how much NumPy is downloaded. Right now it's about 200 million downloads a month. The NumPy package is about 15 megabytes. If you count that up, that is like 36 a year. There were also PyPI blog posts and estimates about the total traffic on PyPI and what that cost in terms of if you would have to pay for that. It's all sponsored at this point, luckily, but it was tens of millions a year already a few years ago, and it keeps on growing. So this is actually, like, from an environmental impact, this is bad. From a community sustainability, it's a potentially very large risk. So like binary size is, it's very important to think about.
In this episode, I have a wonderful conversation with Ralf Gommers, a director of Quantside, and he's a key contributor to NumPy. He actually shares his journey of how he started working and contributing to several open source projects, but more importantly, the journey that he took inside NumPy. So NumPy is a project that most scientific computing projects rely on heavily, and he shares the thought behind the governance model, the importance of having a community, funding models, and how to maintain long-term open source projects. The Inspiring Computing podcast is where computing meets the real world. This podcast aims to trigger your curiosity by talking to proficient and advanced users of MATLAB, Python, and Julia, who use these tools to deepen their understanding of the world, simulate, explore trade-offs, and gain insights that help companies add more value. In addition to this, we will also be talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives the development and what issues they're solving for others to benefit from. Welcome, Ralf, to Inspiring Computing.
Hey, Garrett. Great to be here.
I've been wanting to have you on the podcast for a while because above and beyond being one of the directors of Quantside and being very much involved in NumPy, there's this NumPy 2.0 that came out and you're part of the government circles. You also play a significant role in standardizing arrays, data science formats, and packaging mechanisms. Overall, you're a super inspiring guy, so I'm glad you can make it. But before we get into all of that cool stuff, can you maybe share a few words of who you are and what's your superhero origin story? How did you come from a place of, working in Eindhoven in a company, a lithography machine making company, to the director of Quantside and changing the landscape of scientific computing?
All right. Yeah, of course. I am from the Netherlands. So grew up there. I studied physics there, applied physics. I literally have no formal training in software engineering. So I think I had one course in Pascal, which was incredibly boring. So I didn't touch programming for a few years after. And then I went into research. So I always intended to just get a job in industry and figure out my life. And instead, in the last year of my degree, I figured out that research was actually very interesting. So that's where I started to learn programming because you generate a lot of data, you have to analyze it. But also then I decided I wanted to do a PhD in that same field. And right at that time, there was absolutely no funding available in the Netherlands for any kind of new academic work. So I ended up going to the UK and did my PhD there. And same thing happened. I thought I'd get a job and figure out what's next. And then I got an encouragement from my professor to apply to a postdoc at MIT. So that was the only one I applied to, and I didn't expect to get it, but then I got it. And so then I went to the US. So I moved around. I worked in a few other countries after that. And throughout all this time, I gradually, through doing research, went more and more into learning and liking software engineering. So, for example, I worked a lot with lasers and optics, atomic physics. And for that, you had to control all the experimental settings with like a microsecond resolution. I liked Python until that point, not even good enough anymore. You have to start digging deeper and deeper. So that's how I basically taught myself programming. And it was very early on that in my PhD, that I decided, look, I know some MATLAB, I know some of that stuff. At that point, I went to another place and they didn't have a license for it. So I quickly learned that lesson that like, okay, things that are only licensed can be a problem. Like it's a not so transferable skill set. So I decided to throw that out. And at the same time, at the start of my PhD, I switched from Windows to Linux. I switched from MATLAB to Python, and I started using Vim as my editor. And there were like some very unproductive and frustrating weeks. But I think after a few weeks, I got the hang of everything. Uh, yeah, that's when I learned about not even NumPy because it didn't exist yet then, but Numeric, its predecessor. And I think NumPy was just in development. But no, all of this stuff was very new, just written by a few random people in academia. It had zero documentation. So each time you wanted to know something, like the only place to find an answer is on a mailing list. So that's when I joined the mailing list for a few years. You just see how you don't feel immediately like you can actually participate in a conversation or contribute at all. You learn a lot just by following along for a while. And then at some point, there was a real call for help. And at that point, I felt comfortable enough to stick up my hand and go for it. And yeah, that's how it all started. And then throughout all my jobs, I've done more and more programming over time, but also contributed pretty much without a break to NumPy and SciPy in particular since like 2009 or so.
So you're a very active participant and a developer and advocate, which is super cool. So then, but before we zoom into the NumPy and the SciPy role that you have, you're currently working for this cool company called Quantside. Can you quickly tell us what is Quantside, what you do, and how does Quantside actually help the open source community in general?
Sure. Yeah, I joined Quantside in 2019. It was about a year old then. And since then, we've grown to about 65 people. We're a small consulting company, so we make our money by consulting mostly around the PyData stack. Mm-hmm. In addition to that, we have an open source lab called Quantside Labs, which I started leading when I joined Quantside, and I'm now co-leading together with Tanya Allard. I do more numerical stuff. She does more the like Jupyter, accessibility, and DevOps type things. We both do a bit of packaging because everybody needs packaging.
But then, so this company Quantside, so it's consulting. So there's the idea that you hire core developers for mainstream packages, which people like, and you give them a safe landing place to just help out others using it and then actually work with people using it professionally so that it just accelerates the pace at some of these packages. And is that where you came from around NumPy? Was that kind of influencing your decision with your NumPy experience saying, hey, we need a company around this? Tell me a little bit more about that.
It's not like a company around NumPy. It solved the problem I was having. So I worked on NumPy for 10 years as a volunteer and the user base grew. So the demands got more extreme and also my professional career at that point got more intense. At some point you reach this point where it's okay, this is just not sustainable anymore, which I think is the problem a lot of long-time open source maintainers have. And so I had to decide, what do I do here? Do I just stop or do I try and make this my job? And right around that point, I met Travis Oliphant, who was the CEO of Quantside, at a conference. And we'd known each other digitally for a long time, but we never met in person. And he just started Quantside with the intent also to help open source and make space for it, because he doesn't actively contribute to open source anymore, but he still enjoys it. So he said, okay, why don't you go and lead Quantside Labs and just shape it and figure out together like how we can make this work and help make community-driven open source more sustainable. So that's basically my job description: make community open source more sustainable and provide a home for maintainers, do things that are as impactful for the community as possible.
Nice. So you've actually got a very interesting story. So NumPy clearly is hugely successful, but people think of it and take it for granted, if you will. It's probably that journey of taking a little pet project that only a few subset of people care about to something that the world now relies on. Can you maybe tell me some of the lessons learned around that? Would you encourage people to go through the same journey? Are there shortcuts? Or hindsight, could you have accelerated this? Or how do you think about this?
I think it's actually very rare for someone to start out a project with the intent to change the world or be successful, be used by millions and millions of users. It's more like accidental success in the vast majority of cases, where there's something you're interested in, you want to solve this problem, you think you can do better than the existing solutions out there. And then it starts working and it takes you on this ride that keeps on going. And I think the most important thing you can do is when you realize that this is happening, reflect and make conscious strategies around that. And big part of that is also choosing what to work on and like when not to increase the scope of your project too much. So we're still suffering from that.
Yeah, I think some projects were at the beginning, right? There's a new project, you start, you're solving a problem personally, and then it turns out there's a few other people who have the same problem, but then you get your first users and then everyone wants something, and at a certain moment you're confronted with 10,000 requests, and it's like, I didn't really intend to start with this, and I got to deal with these 10,000 requests. Is that when you stepped up with NumPy and start putting a process around the governance and being able to draw the line of what should be part of NumPy or not, or did that happen later?
Implicit understanding between the few active maintainers who, the larger group of people who interact on the mailing list and so on, but don't actively contribute about how this works. And when you want to add a new feature, you propose it, you have to have a prototype implementation, but you have to propose it on the mailing list. There has to be some discussion and it has to be some implicitly defined bar of this is useful enough. And at some point in time that starts to break down, and it's helpful to formalize how you make decisions and who gets to make the decisions, and importantly also what you do when there's disagreement. And this was a problem for NumPy for a long time, especially after Travis left, and then there were, because he built the original thing, and then now it went way beyond that, but it was done by a small group of people who didn't have all the context, and none of them were like clearly the leader of the project.
Right.
So it was always searching for this consensus between everyone who wanted to say something.
Yeah.
Which means that very often when there is a bit of a contentious discussion about some design aspect, that in the end, the discussion just runs out of steam and nothing happens as a result.
Right.
And I think that putting in place a formal governance helped. The other thing that really helped was just having some bandwidth to do things like having a community call every 2 weeks and have money for a sprint so people meet each other in person for the first time, because collaboration tends to go a lot better when you have some sort of personal connection.
When in the history of NumPy did that actually come to play? So the governance model, when was it actually formalized? Is this something that is 10 years old, 5 years old, 2 years old? It's a little fuzzy in my mind.
Yeah, I think NumPy started in 2005 and the governance was instituted, I think, in 2017 or so. It's now 7 years old, but that was a long time after a period of just doing things with implicit understanding and no written rules whatsoever.
So it turns out that it's a super successful project, and I think there are many lessons learned. I think you were one of the first larger projects that kind of really paid attention to this governance, and maybe you picked it up from other open source projects, but certainly in the Python ecosystem, I think it was seen, or I had heard it as a reference. Okay, the folks at NumPy, they figured out that this is a big deal, and then quite a few other packages look up to you in the sense of, okay, that's a way forward. But there's certainly something to be said about how other people look up to you, because you're setting a standard now. So as the years progress, do you have any standardization activities that you're thinking about to prevent people from reinventing the wheel? Because it feels like what you do is fundamental, and instead of everyone reinventing, it feels like standardization would be a good thing. So do you have any thoughts, and how are you engaged on that?
Oh, yes. I mean, that is effectively what was happening since around 2015 or so. The limitations of NumPy started becoming clear when the volume of users in Python went up and they had real needs on very large amounts of data, and GPUs were becoming a thing with deep learning. And NumPy doesn't do parallelism or distributed computing or GPUs. And then, so you saw gradually people liked the NumPy API and basically all the fundamental concepts. So they started basically copying it, making slight tweaks where needed, and just making things work on GPUs, for example.
Right.
And now there's TensorFlow, there's PyTorch, there's JAX, there's CuPy, and a whole host of other maybe less well-known projects. But that in the end looked like something that could have been standardized much earlier, but wasn't. And I actually sent this is one of the first little projects I did when I joined Quantside Labs. Oh, now I have bandwidth to do more than just respond to bug reports and review code. So I tried to make a little prototype of the subset of NumPy. I called it R-NumPy, which kind of came from, I think, R-Python, which is kind of the subset of that alternative Python interpreter it's written in. And I wrote a very long, nice email about all the motivations behind it and how it could help to do something like this. Basically, that immediately got filibustered because one person did not like the word standard, and the standards are bad, and this will harm development of NumPy and so on. So I thought, okay, this is not going to go too well. Let's try to not do this within NumPy, but take a step back. And so in mid 2020, I reached out to developers of all of these other libraries, and we put together a little consortium to try and see if we could standardize a common set and see what the actual commonality were and where different libraries did different things there's usually a reason for that, right? Like the NumPy design is just a little weird or it doesn't work for some fundamental reason. Like one of the big things was when you index a NumPy array, for example, and you want a single element out, you don't get a 0-dimensional array with one element in it. You get a scalar.
Right.
And there's a few things like that. Type promotion rules, like pretty fundamental things that had weird corner cases, but they were very hard to change in NumPy for some reason or to not break all our users.
Yeah.
But then they don't work on GPU. So we worked a lot on spelling out those designs. And after a year and a half of work, we came up with the first Python array API standard. That took a while because standardization efforts were way harder than I expected and way more work. In hindsight, I should have known. There's the first time we tried this. But now we have 3 versions of the standard and it's implemented by NumPy 2.0, importantly. So we bridged some of all of those things that didn't work in NumPy, but the other libraries needed. So we changed them in NumPy now. And yeah, it's starting to get real traction, like SciPy and scikit-learn are adopting it, Xarray is implementing it, and just new efforts and people are implementing it because it solved this real problem of fragmentation and every library doing a slightly different thing.
Because it feels like the open source community attracts a particular type of person. And often these people are wicked smart, right? And they can move at the speed of light, but they also tend to work in silos in the sense that they come from their own community, right? And some of these communities don't connect as much as maybe as they should because you can live happily ever after in your little bubble and that's fine. So I think there's definitely an added value when one of the stakeholders starts bringing other ones to the table. So walk me through the process. Was this you just like picking up the phone or sending an email or going on creating a few issues to trigger people's attention and then you got a consortium? How did you actually build this consortium? It's not that people have to pay to be a member, right? This is just you saying, hey, we're doing this. Come and join us. This is what the cool kids are doing. How did you do this?
Yeah, so it was actually a combination. So there's a few developers of other libraries that I knew personally. I was actually working on PyTorch myself at the time, which is the quant-side consulting hat on. We have a large team working on PyTorch. And then there were other less well-known libraries that I didn't know anyone from, Flow or JAX, for example, because TensorFlow it's a very large team at Google, but they tend to be a little bit more insular. That required active reach out and finding someone to make a connection to the right person in that team. Aside from that, like there's a lot of effort involved in just running, recording meetings, like making meeting notes, like the stuff nobody really likes doing. So we also sought, as well as the standard itself writing, it was actually easy to get developers of every library, like 1 or 2, put them in a room and say, okay, show up at a call once every 2 weeks. And let's talk about hairy technical design issues and see if we can come up with better type promotion rules. Great. Everybody has idea. It's fun to do. But then it's, okay, now you have to write a detailed spec and publish a whole website with that spec and go over every little corner case and see if it actually works for all the libraries. Right. That's the type of thing we needed some funded effort for. So we actually went through our corporate connections and asked people like, hey, if you're not a community, but you're a company-backed project or you're a large finance company that actually can really benefit from this stuff, can you give us a bit of funding? So we had, I think, 6 different funders at that point. Intel was the first one to come on board. Google, the TensorFlow team at Google pitched in some money. And then they're all on the website, these funders. And that really just helped to do these organizational efforts and the writing of the standard itself.
So I think it's a really good example of you give people space to be creative, right? People come with multiple cool ideas and you want to encourage that. But then at a certain moment, I think there's some added value in bringing it back together again, right? And then once it's together, then you leave people to expand again. And there's kind of like a spring effect that happens in ecosystems and technology. So I think that's very cool because in the Python ecosystem, at least, there are plenty of other places where this effect could also happen or maybe should happen. And one of them comes to mind is the packaging ecosystem. But another one is
Yes.
actually the whole build process, right? So anyone who goes and creates their own Python package, it feels like we've given the world as many options as possible. And they're like gems here and there, but it feels like we could bring it all together. And I think, if I'm not mistaken, I saw that NumPy also recently or somewhat recently changed the way you build it. Can you maybe talk a little bit about that journey and why you chose to standardize it or change from the way you were doing it to your approach, which I think you use Meson now? Tell me more about that journey.
Yeah, and to me, build and packaging is like two sides of the same coin, right? It's like you first have to build something into a binary, and then you have to put it somewhere on a website so everybody can use it. And then there's all a lot of complex tools and standards around it. So installs and environments all work nicely. And Python packaging is very challenging. It's gotten a lot better over the years, but there's still plenty of challenges left. The big thing that happened is, for a very long time, pretty much everyone was building their project with distutils, which is part of the Python standard library. And then when that didn't really work, setup tools was the default thing to extend distutils. But all of that was basically monkey patching on top of already really bad code. And in the meantime, NumPy had its own version of distutils, which did other monkey patching of distutils. And it added like better C++ support, better Fortran support for Blazor, LAPACK, basically all the stuff that numerical computing needs. And then for Python 3.10, there was a long time recognition by the CPython team that they don't really care about packaging. They don't really have anyone who really wants to maintain distutils. They don't like the thing. They want it to just go away. And eventually, I think it was Steve Dower who wrote a PEP that says, let's just deprecate and remove distutils. And so they deprecated it in 3.10 and removed it in 3.12. And it's an incredible amount of work to build a build system. So my initial reaction, I was the default maintainer of NumPy.distutils at that time, and actually have been for like past 10 years, because somehow I end up with a lot of these jobs that other people don't want to do. My first reaction was, okay, distutils is going to now be, it's going to be removed from Python, but it's just going to be vendored into setup tools. So let's wait until they finish it. They announced the plan to clean it up a little bit. And then once that's done, we'll put our NumPy stuff on top and see if that can work or reintegrate it.
Right.
And then after 6 months, nothing had really happened. And I could tell that this was not going to. So at that point, I started experimenting with other approaches. And I was very quickly seeing that there were only two things to consider, which were Meson and CMake. And I knew that what we had in NumPy, in some sense, for supporting numerical computing was better than what either of them had. So I was going to have to contribute to these packages as well. And then I looked at it, and Meson just had better documentation. It was written in Python, and it was just nice. And CMake is more popular, but it was written in C++ and some unholy DSL. So I just liked the idea of contributing to and using Meson better. So I started working on that. And I had to build a package on top called Meson Python to be able to create Python packages, because Meson it was great for C++ and Fortran, but it didn't really know all that much about what a Python package was, or a wheel that you could upload to PyPI, or an sdist when you create a release. So that's the thing we had to build. And then the other part was figuring out how to use all that. So I think it took me 6 months to get the first version of, I started with SciPy. I thought, let's just start in the place that's the hardest. If that works, then everything else will work. So I think it took me 6 months of evenings and weekends to do that. And I think it was only thanks to the pandemic that I had so much time. When you're in a lockdown in the Netherlands and it's rainy, like, what else are you going to do? So I think thanks to that, actually made it to the finish line in a reasonable amount of time.
So maybe just from my understanding, if you were to give recommendation to other large packages, would you recommend them to also use the Meson toolchain instead of the CMake? Or is it because that NumPy and the SciPy are just so dedicated towards scientific libraries and there's such a strong dependency? What are your thoughts here?
Yeah, I think people have their personal preferences, and I think it is just not going to happen that everything will use the same thing. That's what we had with distutils in the past, and it was horrible. So it's actually great that now Python packaging has evolved to the place where if you need something better, you can build it, and then there's standard hooks and ways to plug it in. So as of right now, if you don't have any compiled code, life is easy. Like, you have nothing to worry about, and you have about at least 5 good choices, maybe more. if you do have compiled code, if you have a really old package, you're probably still with setups, or you've recently migrated and then your problem is solved. If you're starting a new project now, I would say using Meson and Meson Python or using CMake with scikit-build core are both, you can't really go wrong. They're very similar. They have different capabilities, but I'd say part of it is just personal preference. Both at least an order of magnitude better than what we had before. I always like it when new people show up and try to use Meson Python, and I try to help them very quickly when they get stuck. My co-maintainer, Danielle, is the same, and there's a few more people on the Meson team as well. So questions usually get answered quickly, but I think it's totally fine for people to use Meson as well. There may be reasons if that's the thing you already know, or you have dependencies that are in C++ and they use CMake, that might just be a better choice.
Just out of curiosity, that you've gone through this journey of being on the sidelines, looking in, and then moving to a place of actively contributing to actively governing. So I often find it when I speak to newcomers who are scared of helping with open source, how do you encourage people to get going? So is there a philosophy, best practices? Because there's the step of, okay, I'm a domain expert. I know something that no one else in the world does. I have a problem. I want to share it. But then you start going down this rabbit hole and you start saying a bit like yourself, oh, now I need to know how to package. Now I need what a compiler is. Now I need different distribution tools and chains and tool chains and mechanisms and versioning. And then you go down this rabbit hole that it feels like that's not what you started off with. So how do you go from this domain expert who wants to help to encouraging the world to help you down this journey so you don't burn yourself out?
This is a really hard question, Garrett, because I would always like to have more maintainers of my projects. I would like to see more and more people contribute and make open source software better. But I'm also aware that it can be a challenging job, and especially when it's not a job. If you have to do it on your Friday nights and then it turns into, it needs your whole Sunday as well, it can be challenging for your personal life. So I would always recommend that people start with solving a problem that they really need solved or that they care about or enjoy solving. And that could be just fixing bugs, or it could be just building a new feature or some functionality that you want but doesn't exist, or doesn't exist in the language or package that you're using. And from there, as long as you're conscious of the time that you spend, I think doing more and learning more, as long as it remains fun, is very much worth it.
So there's a couple of things that I think a lot of open source maintainers, they actually thrive on a recognition, right? So there's the initial thing of solving a problem, but then a lot of recognition is actually what fuels that passion to keep on going and growing. But I often see that then you get to a stage where you become so popular that your day job is no longer just maintaining code. It almost feels like you have to coordinate a community. And that's maybe not where you started with. And I think many projects struggle with that handover, right? It's also a bit like when you have a startup company to a scale up to a large enterprise. It's not an uncommon thing that the leadership changes because you need different profiles. I think with open source, it's no different, but it's often the case that people have a much harder time of letting go of their little babies, right? That they created it and it grew and I don't want to let go of it.
It's very much, I think, the same problem in a company as it is in an open source project. It grows over the head of this one person that started it. And pretty much your most important skill as a project lead at that point is connecting with other people and giving them the opportunity and the permission to, make the project their own. Because if you hold on too long, then you do end up doing it all. And that's usually a very not so good idea. And the people who are good at community management and just not the technical part of code review, but the social part and encouraging new contributors to not only finish this PR, but give them a suggestion for the next one, are often not the same people that started the project with some very deep technical skills.
The other day, someone asked me this question and asked my views. So Gareth, what is your view of generative AI? And I said, I don't understand why you're asking that. And he said to me, it turns out if more and more people use ChatGPT and generative AI, they're actually not reaching out as much as they used to on the community. Do you also feel that people are, because they're using ChatGPT as a sparring partner, they're not engaging as much in your channels? And that's actually a negative side effect for things to go further. Do you see that? Or is that kind of like a perception that people are scared of more than anything else?
No. So we actually have a very topical discussion about code generated by ChatGPT and co? And to what extent can that end up in a pull request? And is that a real worry or not? I think my answer for now is not today, but probably in the future. But it's no different than 10 years ago, people going to MATLAB Central and taking that code from there, which wasn't suitably licensed, and just translating it. I actually don't see a lack of engagement. And it's the type of questions that ChatGPT can answer is the type of thing I don't really want to be answering, right? I want to be asked interesting questions. And I think we're pretty far from the point where it can answer new and interesting questions about NumPy's design or how some piece of code works or something.
So you recently released NumPy 2.0. So this is an awesome achievement. Do you have a favorite feature or something that you want to call out to say that this has been years in the making and you're super proud that it came out? Do you have something like that you want to share with us?
Sure. It was really, we were almost too tired to celebrate, but it was a major achievement. Like the first it was also getting the whole community along was a bit of a journey.
Yeah.
If I think about new features, we already talked about the Array API standard. So that's, of course, for me personally, a highlight, and that we finally managed to get NumPy to adopt the standard. The other one I think I would like to mention is that I put a lot of effort in reducing binary size. And that's something that's not even a feature that most users think about. Like it doesn't end up in the docs or anything, but it's actually super important. And I was on a holiday in Norway in winter, and we were on a train ride, and I started thinking about what the environmental impact is of just not me working on NumPy, but NumPy, the project, putting out binaries there and people downloading them more and more. And I started counting, and I realized that if I could shave off just 1 megabyte off of a NumPy binary, that would save on the order of 200 intercontinental flights a year. There are large error bars on this number. You can go to PyPI stats and it will tell you how much NumPy is downloaded. Right now it's about 200 million downloads a month. Wow. The NumPy package is about 15 megabytes. If you count that up, that is like 36 petabytes a year. There were also PyPI blog posts and estimates about the total traffic on PyPI and what that cost in terms of if you would have to pay for that. It's all sponsored at this point, luckily, but it was tens of millions a year already a few years ago, and it keeps on growing. So this is actually, like, from an environmental impact, this is bad. From a community sustainability, it's a potentially very large risk. So like binary size is, it's very important to think about, and just doing the technical work, which the details are more like find what can be reduced and just figure out how to reshape it or rewrite it in a more efficient way or just cut it out completely.
But did I understand correctly that you shaved it down by 1 megabyte in NumPy 2.0, or is this an ongoing process that you've got a mission to reduce the 15 megabytes to 14 megabytes?
The ongoing mission is make it as small as possible. And there's multiple things that can help. So I still have a few in the pipeline. But to give you an idea, like the x86 version of NumPy package was on average like more than 15 MB. Right now, the latest one that we released for macOS is smaller for 2 reasons. It uses ARM, and ARM instructions are smaller than x86 ones. Also, Apple ships an Accelerate library. So I've been working with Apple on getting that updated and getting it to the point where NumPy and SciPy could use it again. Mm-hmm. The latest macOS installer is 5 megabytes on PyPI right now for 2.0. And I'm pretty sure I can get it down to 3.5 megabytes next year.
Wow, that's super cool. That's super impressive. I'm curious, like when you say you take a project and make it smaller, right? Often people say the diagnosis is that you don't have telemetry. Most open source projects rely very much on how loud people shout and scream at you and say, hey, change this. But I guess at your stage, interviewing individuals is just a very biased view of the world. So how do you actually know what to remove? Do you track the documentation pages of what's being used, what's not being looked at, and then say, okay, these 20 APIs haven't been seen by only 1% of the world? How do you go about deciding, okay, what can I remove if you don't actively get any telemetry? Because I don't think that's part of the philosophy of NumPy or open source.
Yeah, in NumPy 2.0, we actually removed a lot of APIs, but most of those were aliases and duplicates and really niche functionality that we didn't like for other reasons. We haven't removed everything just to make the package smaller. But very often it's a performance versus size trade-off, right? If you add a lot more SIMD instructions, you can add specific optimizations for a particular type of processor, right? Not just an Intel x86 processor, but one from the Haswell generation, for example. And
Right.
there you saw we did things where we shipped 5 different flavors, or in the case of OpenBlast, which we ship as part of NumPy, like 15 different generations of x86 CPUs. And like, why? No one ever did the cost benefit analysis of that. And like, why do we need to ship 15 different compiled versions of the exact same function?
Yeah.
5 or 3 or 1. Right? And 1 doesn't work, it costs too much performance, but it could easily be 5 instead of 15.
There's also a bit of a trend in the Python ecosystem, which is a lot of some packages like pandas versus polars, where there's a whole Rustification going on. I have to ask you the question, what are your views on the potential of maybe using Rust as a backend for NumPy? Or is it like, we don't need that. C++ is fine. No need to worry about it. Too much legacy. Don't bother me with that idea, Gareth.
Don't quote me saying C++ is fine. It's not that fine. But no, so for some existing project, it would be a really big lift to change to Rust. Rust is really popular for good reasons, and it's got some very nice functionality and features, as well as developer experience that I wish I had time to play with. If you have a new project and you don't need anything specific that you need from C or C++, then I would say Rust is a very nice choice for compiled language. It also has very good Python integration. So that's a very different question, though, than can an existing project start using it? Because there's, in NumPy and in SciPy, there's way too much legacy code to say, like, let's all rewrite it in Rust. And also there's some features that Rust may not have. Like last time I checked its SIMD support, it wasn't good. So you still have to deal with the old style Fortran API, and then you have to do foreign function interfaces in Rust, which will probably just land you in unsafe territory.
Right. So the cost benefit's not quite there yet. So indeed, the BLAS part is a big deal. I can see that. But it's often a question that people kind of wonders, okay, is the future programming language, so the new person, so if I'm a university student, should I learn Rust or should I learn C++? Did you have an opinion on that? Or is it just follow your heart and learn one language and then the other one will come naturally?
Both. I think for the next decade, you cannot get away with not knowing C or C++. I think you need to learn at least one more modern language as well. Rust is a great one. I'd personally also be interested in learning Zig, and I like how good Zig is at cross-compilation. And I think, to make standalone Rust binaries, I think Rust can use Zig under the hood because that's how good Zig is at it.
So Ralf, you've spoken a lot about your experience at a company like QuantSight, at NumPy, and multiple projects in different roles. You at this stage have probably got a unique perspective of how open source in general, so independently of projects you're involved in, how do you actually make this more sustainable, right? So there are patterns emerging. Do you have an opinion on what the right way forward is for the world to make this more sustainable and make it flourish at a faster pace than it is today?
Yeah, so let's start with, I don't have the answer. I don't think anyone has the answer today, but it's an extremely important question. Open source runs the world nowadays, right? And a lot of it is community-driven open source. There's also more and more company-backed open source, which has a very different feel to it because it's often one company, either controlling a project completely or at least making all of the major decisions because they employ most of the containers.
But is that a right model to have a company to allocate resources to spend on open source projects? Is that the way you're thinking the world should iterate, that every tech company should say everyone's job is 3 days of work on whatever they're caring about and 2 days should be on open source projects? Is that a way, or is that a very biased view of the world?
What I do see is that community-driven projects are often, because they move a little slower and they have more different voices that shape the design and the direction of the project, they tend to be longer lived and may also be more influential. Whether it's Linux as an operating system, or NumPy, or for example, in the PyData space, these projects have a lifespan of decades, and I don't even know how many decades. Like, it's going to be a long time before it disappears. Right? So to make that more sustainable, I think it requires like a patchwork of volunteers and funded work, because a lot of work is done by volunteers because it is fun, or because they learned something from it, or because they value the connections they made in the community. But then there's the more boring work, or the just really challenging work that you can't do on a few Friday nights, that does require funding and keeping the lights on. And when a project grows in popularity, the need for that goes up as well. Security is another one of those, right?
Yeah.
Nobody really wants to work on security bugs and feel like they're responsible for breaches. So that's something that really should be funded. It could be a combination of companies who already employ maintainers to give them some more work time. Why don't you give them 1 day a week, every Friday, work on whatever you think is best for this defined set of open source projects? Actually, within Quantside Labs, we do the same thing, where we have a combination of stuff we do because we think it's most important for the community, but nobody's paying us to do it. Grant-funded work, which is both institutional funders, like we have a grant from NASA, we have one from a German government agency, the Sovereign Tech Fund, and then we have also non-traditional funders like Chan Zuckerberg Institute or the Moore and Sloan Foundation. Company interaction, where it could be like a big tech company, it could be some smaller company. They need to be able to talk to someone because they cannot talk to a community. They need to be able to say, I have a real problem. I need it solved. I want to sign a contract with you for $100,000. Right? So a maintainer can sit and work on that for half a year. Right? And you need all of these ideally in as much variety and different durations as possible, so that no one's job or the health of a project has a buzz factor of 1.
So what about education and the role of universities in all of this? Because I think a lot of passionate people, they do this also aside of their working careers. They could effectively start at a younger age. Do you think that universities have a role to play here, or even governments for that matter?
Yes, well, both probably, but governance more in the providing money sphere, recognizing what's important. Universities, I think it's a mistake to have courses where everybody has to contribute to open source, because that just leads to lots of inexperienced students sending low quality PRs. And I've seen that happen where that really increases the load on maintainers. But teaching let's say, how open source works, as well as how the mechanics of it work, and teaching Git, for example, right? Like good habits with Git and working with branches and good commit matches. It's all the type of stuff that we don't want to be teaching new contributors. That's the type of thing that everybody who gets computing courses or does a computer science degree, or nowadays, even if any kind of engineering or physics or math degree, should just learn. It should be an expected basic skill.
So it's interesting because it's quite often the domain experts, they are focused very much on their domain, and then the software carpentry skills is a afterthought. And then it turns out that afterthought is actually the hinge point of making their work visible or used by many other people, which in turn is actually what gets them the recognition of being recognized as the best in their fields, right?
Oh, yes. I've seen the academic person, the domain expert, writing some code firsthand, because that's what a big part of SciPy consisted of, right? It was just academics, mostly writing in Fortran, somebody else taking that code, putting Python bindings on it, put it all together and call it SciPy. And we're still cleaning all that stuff up because the quality of it was absolutely terrible. It was mostly Fortran 77, and it's incredibly buggy and almost impossible to debug.
If people want to reach out to you and participate, what is the right way to reach out to you?
It depends on whether you want to reach out to me or to a project. So it's typically an anti-pattern, unless you have a very specific question and you actually need me or someone to reach out to a maintainer in private. One thing we did for both NumPy and SciPy is set up a Slack workspace, because most people don't want to say in public, hey, I want to help, I don't really know where to start, right? So join the Slack workspace, and then you can ask that question like a dedicated channel for newcomers where some of the maintainers hang out.
That's it for today's episode. I hope you enjoyed the conversation and found it valuable. If you did, please consider sharing this episode with your friends and family, or anyone who might benefit from it. Also, I'd love to hear your thoughts, so take a moment to leave a review and let me know what you think. And if you haven't already, don't forget to give us a rating. It really helps us reach more people and bring you even more amazing content. Thanks for tuning in, and I'll catch you on the next episode.